I'm glad you all made it. This session is system performance review for InterSystems IRIS applications. My name is Murray Oldfield. I'm a technology architect at InterSystems. I spend a lot of my time talking to customers, people like yourselves, to vendors and our internal development teams. And I spend a lot of my time understanding how customers' systems are running, doing capacity planning and performance analysis if they're having performance issues. I talk to the vendors because if you're getting some new storage or you're moving to the cloud, quite often the vendors don't understand how IRIS works. So we have an education session, usually it goes both ways, and it's a bit of education on how IRIS does its I/O, for example, or how we're an in-memory database mainly, and and we work out what's the best way to deploy IRIS applications on whatever infrastructure it is that you're going to be using. Today, we're going to run through some stuff. Now, if you have questions, just put up your hand or stop me if I don't see you. While we're in the session, I'll just repeat the question and answer it if I can. At the end of the session, if we have time, we can do the microphone thing. So if you hit a bottleneck in system resources, your users are going to suffer. And really that's who we care about, or most of us pretend to anyway. And to ensure the systems are right-sized, you're going to need to understand how they're running, how they're using the system resources, whether you're getting near to the end of the capacity that you have, so that you can take action if you need to. If you're refreshing your infrastructure or you're moving to the cloud, you need to know what resources you're using now, if you've got some growth planned or whatever, what you're going to do with that, so that you can right-size as you move on. If you're staying on premises, you're probably going to be planning out for maybe 5 years, the life of your infrastructure. There's a lot of metrics available to collect, and I spend a lot of my time, I might see in a week 3 or 4 customers' data come in. I live down in Australia, so in the Asia Pacific region. A lot of the customers I deal with are in fact the track care customers, the InterSystems EHR system, which we sell outside the US. But I also see systems from lots of other people as well. What we're going to look at is just a few key metrics. It's surprising how few you need to look at to do a quick evaluation of your system. Now, if you find something that's got a problem, then of course you can dive deeper, and we can talk a little bit about that too. So, common questions you're asking, you're monitoring your systems, you're understanding, you're trying to get a baseline, you're trying to understand what's normal on your system, and you're not going to understand that unless you're monitoring all the time. You really need to put something in place so that you get the beat rate of the system, you know what your business cycles are, if something's happening at the end of the month, and a lot of system resources are being used, well, that might be just normal. There's troubleshooting. There's a bunch, pretty much the same metrics you look at are, if you're starting to get telephone calls from your users saying, my system's slow. Well, what does that really mean? Is it slower than yesterday? Is it slow because of the network? Is it storage? Or have you run out of some resource? Or is there something else happening on the system using up those resources? So there's a heap of system metrics available within IRIS already. Down the left-hand side of the screen there, you can see just a little extract from our online documentation, which has been updated quite recently. And I'm only going to pick out a few metrics and a few things to look at. One of them is there was a session on observability a couple of days ago given by Bob Kay. So that's using the SAM tool. Is anybody here, did anyone go to that session? So only a couple of people. Has anybody used the SAM tool? Okay, a couple of people as well. So I'm not going to show you even a picture of it. I'm just going to tell you what it is. What it is I'm getting a lot of echoes. Maybe another mic's on or something. And so what it is there's an API endpoint now in IRIS, and it's been there for since 2019, I think, that if you do a curl, for example, to the endpoint, you get a whole lot of metrics back. So where in the past you might have had to go onto the system and type mgstat, and you get, everyone know what mgstat is? So this gives you metrics that come out of IRIS itself, things like global references, how many reads and writes you're doing, and some other useful things. It also has a alerts endpoint, and what they're used for is that SAM tool. So what SAM is system alerting and monitoring. It's actually InterSystems, and we're doing this a little bit with other things as well. It's a couple of open source tools. One is Prometheus, which is a thing for consuming the metrics you get at the endpoints. So, for example, this one is saying, we've got CPU usage, and that'll be a number. We've got number of CSP sessions, cache efficiency, how much database free for all your databases. So all of this information is available now just through an API call. Now, Prometheus will consume that in a time series database, and then hand in hand with that goes another visualization tool called Grafana, which you can build dashboards and you can do charts. So you can see like your CPU usage over time. You can get a lot of system metrics because these are open source tools. They're used a lot in the cloud. They're pretty much standard as far as that goes. So whichever operating system you're running, there'll be a set of agents for that, which will expose just the same way we do. So what does that give you? That gives you the ability to map together things that come from IRIS and from the operating system as well. So you could map Glorefs and CPU in one chart if you wanted to, and use your imagination after that. There has also been added to this recently like SQL metrics and some other things as well. And the great thing about this, and what that session covered earlier in the week, was you can start to add your application metrics there as well. So if you're a health system, you might want to add your interface. In fact, there is some interface counters already in there, but you could add some application-specific ones. We run track care. There's no reason why we couldn't put the episodes of care in there, so we could be plotting that at the same time. So you as an administrator or someone looking after the system has the ability to see what's normal again. I'm doing this episode, many episodes per hour or minute or whatever it is you're counting, and this is my CPU, and this is normal. When those, if the episodes are down and the CPU's up, then maybe you've got an issue. So that's just something to take away and have a look at. What I'm going to look at mostly today, because I'm one step away, I'm not the customer, I don't have access to the customer's systems. So I use what used to be called P buttons. Now in IRIS it's called system performance. How many people have run either P buttons or system performance? Like most people. So it's a great tool for me because its original use was by the WRC. What they did is if you were having some performance issues, you could run P buttons or system performance over a certain period. It all collates system things like VMstat and IOstat in Linux, and as you would have seen, or Windows perfmon in Windows, plus a whole lot of cache statistics and a few other things. But why it's good for me is because I can just ask a customer to send that to me, and then I can start to look at their system resources, and we'll look at that. So one of the main questions people ask me is, if I start running this, am I going to actually start impacting the system I'm running on? And the short answer is no. All it's doing is collecting system metrics that were being collected anyway. And that's the same for VMstat and IOstat. The kernel is already collecting that. We're just picking it up. So there's really no overhead to running this sort of stuff. And in fact, for our track care customers, I get them to run it 24/7. So every night it kicks off a job for 24 hours to run a system performance. It puts it in the output in a directory, and then they have a cron job or something which will zip it up and maybe archive it afterwards. The reason I mention that is because the default directory for it is the same as the MGR folder, the same folder that IRIS is installed in. And we do that because we know that folder exists because you've got IRIS running. But if that disk fills up with your system performance data, then things grind to a halt and you've got a bigger problem. So one of the first things I tell people, or when with our track care customers, for example, we get them to put it on like a backup drive or somewhere where we know that if things go wrong, there's no issue. Yeah. It has a menu to start with. You can create your own sampling periods and so on. If it's running and you need the data now, because you want to look at what's running in VM, what the performance was like, you can actually do a collect which will list off or dump off the HTML files straight away. You don't have to wait till the end of the run, for example. Most customers running 24 hours every 10 seconds is fine to get a baseline of your system. If we're looking at a performance problem, what we'll do is come down to 2 seconds or 1 second, because that gives us the granularity we need, and I'll show you that in a little while. Yes, so this is not the tool, this is a tool. Yeah, so if you've got a performance problem and you're talking to the WIC, the question was, would you run buttons as well? So buttons is the same sort of animal, but it's collecting different metrics. It's more a cache profiling thing. And from those other slides, there's even more tools where you can start to do a deep dive if you need to. Yep. The slide I skipped was just this one to show what it looks like, and seeing most of you have run it. Basically, it dumps out an HTML file, and the whole idea there is just it's all in one place. You've got one file to zip up, one file to send to the WRC, or one file to send to me. Now, you can see this MG stat here has lots of columns, and unless you're born in the Matrix or something, then you're going to have trouble reading that. So many years ago, I got sick of cutting and pasting out of there and maybe sticking in Excel, because it's so much easier to understand what a system's doing by looking at something visually. So over the years, I've worked on a tool, and in fact Fabian, who's sitting here in the front, he's worked on iterations of this as well. We used to have YAPE, Y-A-P-E, yet another P buttons extractor, but it's not called P buttons anymore, it's called system performance. So being the sort of person I am, I rewrote it again and called it YASPE, yet another system performance extractor. And so that's, its purpose is to enable me to do my job easier, to do these system performance checks for customers. And what it does is it will go through all those columns and MGstat and VMstat and IOstat and so on and chart them all out, so I can flick through them really quickly and start to look for patterns of what might be a performance problem, get a feel for the system. It'll put stuff out either in HTML, which you can sort of zoom around and look at stuff close up, or just in a PNG file, so you've got something to cut and paste into a performance report, for example. And it's on GitHub, so you can just download it it's written in Python. So if you run Python on your system, you can just run it natively, but it's really designed to be run in a container as well, which might make some people's hair stand on end as well. But its basic job is to read in pbuttons file and stick out a whole lot of meaningful stuff that humans can read. I'm having a bit of problem with the clicker. The other thing that I'm doing at the same time, because all of this information is available in the system performance HTML file, I'm pulling out things that I need to know about, whatever system this is. It's got 56 cores, it's this processor, this much memory, what my shared memory is, whether I've got huge pages turned on and things like that. And I'm starting to build out a checklist, like a pre-flight checklist, so that when I'm looking at a customer system, especially if I haven't seen it before, I can start to say, I don't have to go scrolling through the CPF file that's included in pbuttons to see, is freeze on error enabled? Is huge pages set? If it's not, what are the recommendations? So I'm starting to build that out. So as you start to use that, you'll see more and more information in this part as well. So it's, like I said, I'm building these tools for me, but there's no reason that you guys can't use them. Okay, so what metrics do we want to look at? Well, I put this up because sometimes you're looking at something and it's not what you thought. Sometimes you have to sort of go that next step. And I guess that's part of this session today, is for me explaining a little bit more. So we're looking at resources. So any system is going to have a certain set of resources, and I group them by CPU, memory, and I/O. I/O is network and storage. And we're looking, essentially what we're looking for, or what I'm looking for, is latency. Latency is wait times, and eventually that's going to impact your end users. If there's some resource in there that's overutilized, it's going to have a high latency. And the other question is, when we move to the cloud, what do we look at? We look at exactly the same things. Remember, when you're running on premises, your server has CPU and memory, and you've got storage. When you go to the cloud, you've got the same stuff. The important thing is we're using exactly the same tools to look at it as well. But when we get to the cloud, there's limits all over the place, artificial limits put in by the cloud vendors. And they will open those limits up if you pay them extra money. This is important because if you're thinking of uplifting from on-premises to the cloud, you have to understand what resources you're using now to be able to cost properly as you go up. Because if you need higher IOPS than they sell you at the base rate, then you're going to be paying more, and you're going to have to start making some decisions. So let's look at a few of them. I use this use methodology. It's basically you look at utilization, saturation, and errors. So for something like CPU, we're looking at CPU utilization over time. The saturation is queuing, so whether it's storage or CPU. So queue in CPU would be your run queue, the R in Linux, and in Windows it's I forget what it's called but there's I'm using Linux in all the examples, but pretty much everything applies to Windows as well. And errors is just, if you're getting errors, then things are probably going to be running slowly as well. So CPU, most people understand a CPU chart. Everybody looks at it, on your laptop or whatever. So your utilization is, how busy you are. I usually size systems to be 80% or less. The run queue is the number of jobs that are, think about a supermarket with the aisles. And so this system has 48 cores, so there's 48 aisles in the supermarket. If I've got 48 jobs ready to run, I don't have any saturation. It means everybody can just keep going through. If I have 80 jobs now in my queue, then some people are going to start to wait. That might be fine. They'll clear off maybe pretty quickly. If they start to, you've done this on the highway, got so many lanes, somebody breaks down on the right-hand lane, and suddenly the queue sort of starts to go, and then bumper to bumper, and then all hell breaks loose. And the same thing will happen to a CPU. If you don't clear that saturation, then things start to bottleneck and back up, and then you get a situation where things do fall off a cliff. The other type of saturation is wait on I/O, and I chart that because this is the time that a process is ready to run on the processor, but is waiting on a resource, and usually that's a disk resource for wait on I/O. If that's bumping along at single digits, that's usually fine, but once that number starts to go up, it's a clue to me that I want to go and start looking at the storage, because typically it's a storage problem. So once the wait on I/O comes up, it's the processor saying, I want to read some data off disk, and it's just not available. You've got to get in there. The process will start spinning, and this wait number here will go up. So we'll look at memory. There's not so much to look at memory, but one of the things that I quite often see is, and a question that comes up in Linux especially, is if I see my memory free drop down, does that mean I'm running out of memory? Has anyone seen this before? What this is that Linux systems have file system cache. So the Linux system will use the file system, will use the memory to do read ahead, for example, for reading off disk. And it'll start to cache IOs, your IOs in memory. Now, that means that the free memory goes down, but the important thing to remember is that that type of memory use is let go immediately if you have an IRIS process that needs that memory. So I get quite a lot of calls where people say I'm running out of memory, but it's not. As soon as it looks like it, but it's not an actual fact. The other thing that happens is, so we can see sort of the effect here. There's a lot of reads going on this system. Doesn't have direct I/O, so it's using file system cache, and that's why these two things correlate. And the other thing is paging with memory. Page outs are fine, but if you start to see paging in, like not here, then you've all heard those analogies that if a CPU cycle is 1 second, then coming off cache is some other time, and then coming off disk is weeks and weeks. Those charts that you've seen. So we have to size our system so that we have adequate memory for all our shared memory for global buffers and routine cache and locks and all of those things, plus enough memory for all your processes, your IRIS processes. So if we have a look at cache IRIS quickly, I always have a look at and want to understand how a system is traveling. There's a really good correlation between global references, which are database accesses per second. So this system is doing 15 million database accesses per second. So anytime a global is touched, whether it's in memory or anywhere else, that's a global reference. And that you can see that that's tracking with the CPU utilization. So if your system is starting to use more global references because your application has changed, then you're going to see your CPU go up. If you can make your application more efficient, your CPU utilization will go down. But for a first pass, you just want to know what the patterns are on your system, what's normal, because this is one of the areas where I see big changes. Somebody puts a patch on, an index isn't used, something's not very efficient, and suddenly the global references increase, and that means the CPU increases, and then everything starts slowing down. Read ratio is interesting to look at, just simply because it's logical block reads to physical block reads. So remember cache is an in-memory database, so the data set that I'm working with, ideally you want that up in memory. You don't want to be reading customer data off disk. You want to have enough global buffers there that your working set for the day mostly is already in memory. So we can see on this chart here that more is better. It means I'm reading more of my data blocks out of memory than I'm reading off disk. And then maybe someone's running a report or something like that. The data's coming off disk now. My read ratio goes down. Well, that's okay. Like, it's not the end of the world. But if that happens for very long periods of time, it means that other things will start to slow down because your global buffers will be starting to be not having useful customer data, but whatever was going on that was pulling everything off disk. One strategy is if you have a lot of ad hoc reports or something that runs, to put them on an asynchronous mirror, for example. Just take them away from the primary system. And then storage. This is the area where I find now most of the problems I see with customers are now with storage. It used to be the network. We always used to blame the network, mainly because we didn't know much about it. It was always easy to blame someone else. Now when I see systems running slowly, it's quite often a storage problem. And that's a couple of things. One, we went from hard disks to SSDs, spinning disks, and that took away a lot of the bottlenecks in storage. And everything was good for a few years, but then we started to get software-defined storage, things like Nutanix and vSAN and all the other flavors of that, where it's not the traditional storage array with fiber channel, it's some sort of network system with lots of servers. If they didn't understand how IRIS worked, they could get overwhelmed and your storage would get slow. And as we move to the cloud, this is probably the biggest bottleneck as well in the cloud. So this is something I'm going to talk a bit more about now. I'm not asking you to read this, but what we do in our documentation, we have recommendations for average response times for the different types of IOs. IRIS uses database random reads and writes. So your 8K reads and writes that are going randomly. We like those to be single digit. And journals, they can be, remember, all your transaction journals are being written constantly, where the database writes are written every 80 seconds and the reads are happening constantly. And we also have the write image journal, which is a big sequential write just before the database random writes are put out. That's important because it's probably the WIDG, the write image journal, which upsets most of these software-defined storage systems. They don't cope with a particularly large sequential write unless we do some strategies to help them along. Most obvious place is MGStat. It tells you what IRIS thinks it's doing. So IRIS is doing physical writes and physical reads, so they're easy to chart and have a look at and understand what your system's doing. But really you need to understand the latency, which is the important part. You might be doing this many reads, but if you've got a lot of latency, that's when things are slow. So your user's at the end of the line with a screen waiting for some information to come. If there's latency way down on the storage because that information hasn't come off disk, that's when they start getting impacted. So looking at writes first, what you want to see is nice spiky writes. They're being every 80 seconds, they're being written out, in this chart here, 8,000 IOPS a second. This is sort of across the day here. This is zoomed in down the bottom. Whatever they're doing something interesting. They're doing, every hour, they're running some job that's doing a whole lot of updates that takes about half an hour. So that sort of thing is what you're interested in. Is that normal? Is that something run amok? Is that something that could be moved somewhere else? So these are the type of things you start to see when you start charting. This is a system that it's very busy. It's doing about 60,000 IOPS per write daemon cycle, which is quite high for IRIS. But what we're seeing here when we zoom in is that we're not getting that nice spiky right. We're getting this one here that's starting to, dribble, have problems getting up to speed and then dribbling along. So there's some sort of bottleneck on that system. And there's sort of an argument to say that as long as your write's clear before the next write daemon cycle, things are okay. But we can see in this case that we're actually overlapping write daemon cycles. And that can be a problem because, somebody's pointing.
I have a question.
Yeah.
So would you say that you say writes and people assume like a set, right? But also the kills, like someone's running a purge.
Yes.
That's the same IO, right?
Yes. Yeah, and remember your journals are going to be used as well. So one of the things I often see with customers is they'll have some big, like an audit database or a metrics database that they kill. It might be massive, it might be hundreds of gigabytes. All of that's going to be happening in the system on disk, but also all of those will be journaled out. And you can actually see a system crater when all someone's done is just done a massive kill.
And the database extends too, right?
So the strategies around that are to either do it in little bits, so it doesn't, or do it out of hours, or do those type of things as well. If your write daemon latency does get too high, it can trigger a mirror failover. It's not a happy place, so you want to keep an eye on that. Looking at reads, so we're looking at the RA weight in IOstat, or in Windows it's called the average disk seconds per read. This system here, I'm looking at it, and it's got a read latency mostly less than about 5 milliseconds, which is good. It's within our parameters. But here on the right-hand side, it's way up. It's up in the 50s, and that doesn't look very good at all. But then on a second look, we zoom in and we can see that actually it is quite good. It's just the way the charting works. So that's that chart I showed you at the beginning about correlation is not causation, or whatever, the other way around. Looking in, we can see that there's just a few little spikes above 50, and probably for a normal system you can get away with that, and it's not an issue at all. But this is a case of just diving in. And probably one of the most important things you can start to think about is actually putting metrics in your application. I've talked about the things that come off the operating system, like VMstat and Windows Performance Monitor and the MGstat, but once you move on from those things, you should really be looking at things in your application you need to measure to understand the service that you're providing to your end users, the metrics that are important to your business. For a health system, it might be looking at the number of the component response time. By that I mean in TrackCare is a web-based EHR system. And so the screen is made up of components. So that's how that TrackCare is built. So a component might be a list, or it might be an entry screen, or it might be a chart, or something like that. So when we build TrackCare, we build metrics into the application itself, so we know how long it takes to build that component and present it to the end user. And by measuring that component response time, we get a good feel for what is the end user experience. Now, if that gets too high, the users start complaining. So we need to know those, and what we do is we regularly review those for all of our TrackCare customers that we can, and look for trends. If something's starting to trend up on time, or global reference use, for example, then we know that some action needs to be taken. That could happen because an index is not being taken advantage of, for example. Other things you might care about are things like episodes or encounters, or whatever the transaction is in your business, because you want to know what's normal, how does that relate to CPU and things like that. So these are a couple of things that they're a little bit small on the screen, but for example, we track the database growth over time. So if I'm doing capacity planning, I know that I'm using this much database. The data database is growing by this much per month, the audit database by this much, and so on and so forth. So I can start to plan or look for anomalies. The other chart there is just, we track the episodes per day, so we know that, what's normal. Is it trending up? Are we going to be having to add capacity faster than we thought? Here's a look at the component response time. This is just a component I picked off one of the systems, and it's interesting because we're travelling along here. This component, every time it's called, it could be a screen, it could be a list on a screen or something, it's doing 1 million Glorefs every time someone presses the button, and it's taking about 1.5 seconds to prepare that, and then it gets sent off to the user, to be displayed on the screen. But then, and that was actually a problem, because once things get around 2 seconds, users start to notice. So a patch was applied to fix whatever the problem was. The number of global references dropped way down to like under 200,000, and the response time for the user dropped to less than a second. So if you're keeping those metrics, you can tell if, has my patch made things worse or better. And for your applications, you know which are your busy parts of the application that you want to keep track of. For the cloud, the message is there's limits everywhere in the cloud. You can't just lift and shift. You might be able to get away with it, but you really have to put some thought into it first. So I'm using AWS as the example here, but it applies to all, Azure, GCP, Alibaba, wherever you've got your stuff running. So the way they sell cloud instances, like think VM, it's like Lego. You buy a certain block size. So for IRIS systems, quite often we recommend the memory optimized systems, which are the R5s or the R6s, and they have basically a 1 CPU to 8 gigs of memory ratio, which sort of fits our model nicely. But you buy a certain size, so you don't want to buy more than you need, and maybe you want to buy enough for the next 6 months, and after that time, if you're still growing, then you can, if you're mirroring, you could fail over to a larger instance. If you've got some reason to go down, you could fail over to a smaller instance. So, but the main point is here, you're buying certain block sizes of instance. But they all come with limits. They have, this particular instance type has performance of 10 gigabits per second for networking. It allows a certain type of storage. EBS is what they have in in AWS. And the storage bandwidth is 9.5 gigabytes per second, which sounds a lot. But there's a trick. It's not so much what's on this chart, the fact that there is a chart is, for these EBS disks, which are these ones here, the GP3 and the GP2 for AWS, for example, they have certain volume sizes, so up to 16 terabytes. Maximum IOPS is 16,000 IOPS, which sounds a lot, until you notice that out of the box you only get 3,000 IOPS. Basic cable is 3,000 IOPS or 125 megabytes per second of bandwidth. Or pay more and you can uplift those limits. So that's why you need to be monitoring your system. You need to know, are you going to fit in this, or are you going to have to think about it and do something else? So there's even more depth to this. Things like the GP2 disks are sized at 3 IOPS per gigabyte, and Google Cloud is 6 IOPS per gigabyte. So if you need a certain IOPS, certain I/O rate, then you're going to have to buy a certain size disk. So these things all start to come into play, and if you want to, especially start increasing, then you're going to have to start paying a lot extra. And talking to one of my colleagues, he was saying that looking at, for example, the GP3 costing, it's a bit of a hockey stick. Going from basic to paying for more IOPS out of the box is going to cost you more. So there's a couple of ways we get around that, and I just sort of mentioned this to have a think about. We use LVM in Linux a lot. In Windows, it's called something else. But the idea is that what you're doing is you're creating a logical volume out of physical volumes. This is something we did in Linux on premises all the time. But you can also do this in the cloud. So I've got 5 50 gigabyte disks there. So they're not very big. But remember, they come out of the box with 3,000 IOPS each. So I create a stripe across them. So in a round-robin fashion, the data just gets written out and spread out. So now I've got a 250 gigabyte disk, but I've got 15,000 IOPS out of them now, and 625 megabytes per second is my maximum bandwidth. Now this is just an idea, and it works because I've run benchmarks to prove it. So here's those 5 disks running at 15,000 IOPS. This is using Random Read, a tool you can download off the developer community, and you can see it just steps up, and once it hits the maximum, this is running in AWS, you just flatten out. And the way they flatten out in the cloud is on the right-hand side here is our latency. So they just increase the latency of your storage. Remember what we were talking about, increasing latency makes your users wait longer. But that's how the cloud vendors will throttle you. They'll just increase the latency on whatever resource you're looking at. And for writes, one thing I did notice when I ran the random write test on the same disks, I could actually get above 15,000, even though they say that the type of disk I was using, the GP3, doesn't have a burst, which they sometimes have. By the time that the writes had gone out, AWS hadn't realised yet and put the throttle on. So I don't think you can guarantee that, but it's just an interesting data point. All right, so we're just about at the end. I think, remember that, this is an introduction, this is a bunch of things to look at. I think the real message here is just start monitoring your system if you're not doing it. Start monitoring your application is probably actually where you're going to get the most value, because that measures more what your end users are in touch with. Start quickly at high level and then start working down. On the developer community, which you've heard about a fair bit this week, if you just look for me, I have a section where I talk about these type of topics. It's been very VMware heavy in the last few years. I remember, in the mid-2000s to the 2015s, the big question was, can we move our IRIS application to VMware? It became, early adopters did it, and then just everyone does it without thinking now. And now we're moving into the cloud. The same question's being asked, can we move our IRIS application to the cloud? Yes, you can. But as we saw, just remember there's limits everywhere. Measure your system, understand what it is you're moving, and then you should be fine. And of course, there's a whole bunch of other skills to learn to get it up there. We have 1 minute and 27 seconds left. You can either go for ice cream straight away or ask questions, or I'll hang around at the end. Yeah.
Will we be able to retrieve these from the app that we have on our phone, or log in and save them as PDF or something?
Yeah, so the question was the slides themselves. Yeah, they're in the app. They're in a slightly different order. I'll leave that to you. I didn't change much. I just changed the flow a little bit. So yes, they're there.
Thank you.
And go to the developer community. The things I've talked about are in a lot more detail there too. So any other questions? Yes?
One quick technical question. The slide where you were graphing the memory versus disk I/O on Linux, and the memory available in memory, something went down.
Yeah.
Just to be clear, you were graphing those because the memory was going down because of the increased disk activity, like disk activity needed more, so all of a sudden the available memory drops in order to cache data, so disk reads.
Yes, so that was illustrating that because we were doing a lot of reads off disk, that the file system cache sort of came into use, and the file system cache is a chunk of memory that got used.
All of a sudden you see the available memory drop, but that's not a problem.
Yeah, but if you'd kicked off a whole bunch of IRIS processes at the same time, then that memory would immediately be given to those IRIS processors and the file system cache would just get lost.
Understood.
Cool. Most of IRIS now is direct I/O, so the file system cache is actually out of the picture, but there's a lot of people still using the earlier versions of IRIS and cache.
Yeah, the nmon m function shows the file system cache.
Right.
It's pretty cool.
Yeah, and yeah, so I've shown you one way of looking at things. This is there's so many ways to look at this data. Yes?
So you talked about the benefit of application level metrics.
Yes.
Because it associates a delay with something logical, right?
Yes.
How do you do that? You actually have APIs that we can call and embed within our logic, and then
Yeah. So
we just do our own.
So the question is, how would you put in application metrics? I would suggest now that you look at the same way that SAM is exposing all of those IRIS metrics and some operating system metrics, because there's classes there that you can call and you can put your own metrics. And when the sessions come out, because they're all recorded, go back and have a look at the one that talked about SAM, because Bob actually did an example of putting in some metrics and displaying them at that endpoint. So basically it's like an API. So the idea is too that you don't have to consume that stuff on the /metrics endpoint with SAM. You could output that to Datadog or Splunk or Nagios or any number of other things. Now it's available in, so yeah, have a look at that. That would be my suggestion. And David Lovelock at the back of the class session has just put up his hand. I'd go and have a chat with him.
What you're talking about with SAM and exposing those metrics is a great way of exposing the application metrics, but how you actually gather the application metrics is something
Yes.
that's very application specific, and we've
Yeah.
got a lot of experience with that with TrackCare and others, and I'd be very happy to talk to anyone about how you go about doing that.
So is that where you can overlap what's in system performance in a graphical way with what's happening logically in the application? Say you're running a particular report? Or
How you actually display it is,
Yeah.
Nari said,
Okay.
there's a million and one ways to display it. But once you capturing the information
Yeah.
is necessary.
Yeah, so if it's in a time series and it's on the same tick as your other metrics, then you can chart them together. You could, something like the storage, you just want to see how much did it grow over the years. So you might want to know whatever that your transaction is, how much disk space does each transaction, we know with TrackCare how much each transaction takes, for example. So it really, we're giving you a box of tools here, to be perfectly honest. All right. Okay, that's great. It's time for ice cream. Thank you very much. See you guys.